Welcome back, geometers. Okay, this is a special video for special triangles. These are the 45, 45, 90s, x, x, x rad 2, 30, 60, 90, x, x rad 3, 2x videos. Okay, we are on page 496 in your textbook, and I'm going to explain it the textbook way. You are going to also hear me explain it different ways, because these are the things you're going to see all the time in everything trigonometry. All right, this is what the book gave us an example for, and example 5 on page 496. So let's go through it, right? They told us that we have a, I like to fill in all the angles. They gave us this 45, I put in that 45, and they said 1, 1, 1 rad 2, right? 1, 1, 1 rad 2, x, x, x rad 2. All right, so what's the sign? Let's just pick a 45-degree angle. What's the sign of this? It's going to be opposite over hypotenuse. So I need to do some math. 1 over rad 2. I got to multiply by rad 2 over rad 2, right? I don't like the denominator, so I multiply by itself over itself. What do I get? I get rad 2 all over 2. Okay. Sorry if you can't see that because I'm trying to color code it. Let's see. Rad 2 over 2. That's better. All right. What about cosine? Cosine is going to be adjacent over hypotenuse. 1 over rad 2 times rad 2 over rad 2. So I get rad 2 over 2. And then finally, what's the tangent? Opposite over hypotenuse. 1 over 1 is 1. All right, but wait. What if it wasn't 1, 1, 1 rad 2? What if it was 5, 5, and 5 rad 2? All right, so what if I redo the triangle? I just expand it, dilate, 5, 5, 5 rad 2. So let's still take this angle, sine of 45 degrees. I get opposite over hypotenuse. Well, wait a second. 5 over 5 rad 2. This can cancel out to 1 over rad 2. And then I have to multiply by the denominator over itself because I don't like the denominator. And I get rad 2 over rad 4, which is 2 rad 2. And it's the same thing. All right, well, about cosine? Adjacent, 5 over 5 rad 2. We're down to here. The 5's cancel out. We're left to 1 over rad 2, which is still going to get us rad 2 over 2. And then what if about the tangent? If this is a 5, 5, 5 rad 2, 5 over 5 is 1. So it looks like I could have a triangle of size 1, 1, 1 rad 2 or 5, 5, 5 rad 2. What if I did x, x, x rad 2? What do you think's going to happen? Let's see. Let's look at the sign. The sign is going to be opposite over hypotenuse. What's going to cancel out? The x's turn into 1 over 1, which is 1 over rad 2. Now we already know, we have it here and here. What happens with 1 over rad 2? It becomes rad 2 over 2. Cosine, x over x rad 2. Looks familiar, right? Same deal. And then finally, tangent. What's x over x? Anything divided by self is 1. So it doesn't matter the lengths of the sides. If it's a 45, 45, 90 right triangle, an x, x, x rad 2 right triangle, the sine is always going to be rad 2 over 2. The cosine is always going to be rad 2 over 2. And then finally, the tangent is always going to be 1. All right. Next up, what about 30 degrees? So let's go with what the book said. 30 degrees. What's the opposite? We're looking across. It's going to be 1 over, what's the hypotenuse? 2. What about the cosine of 30 degrees? Okay, what's the adjacent? It's rad 3 over the hypotenuse, 2. Okay, now finally the tangent, we're going to probably have to do some math. Opposite over hypotenuse, tangent. Opposite over adjacent, 1 over rad 3. I don't like the rad 3 down there, so I need to multiply by itself over itself. 1 times rad 3 is rad 3. Rad 3 times rad 3 is rad 9, which is 3. So we have 1/2 rad 3 over 2, rad 3 over 3. All right, let's see what happens. What if I make it not a 1 rad 3, 2, 30, 60, 90? What if I make it a 5 rad 3, and a 10, right? X rad 3, 2x. What if I do that? All right, let's see. Opposite over hypotenuse. 5 over 10. 1/2. Adjacent over hypotenuse. Let's do some math. Adjacent over hypotenuse. 5 goes into 10 2 times, and I'm left with rad 3 over 2. Tangent. Let's do some math. Opposite over adjacent, right? For the 30 degrees. Opposite over adjacent. Opposite over adjacent. 1 and 1. We get 1 over rad 3. I don't like the rad 3. Multiply by itself over itself. What do I get? Same up here. Rad 3 over 3. So what if I just said any number? Any number rad 3. 2 times any number. What do you think is going to happen, right? X over 2x. Just so you can see. X over 2x. X goes into x 1 time. 1/2. X rad 3 over 2x. The x's cancel out, and we're left with rad 3 over 2. Look familiar? And then finally, tangent. X over x rad 3. X over x rad 3. Just like those 5s, the x's cancel out, and we're left with 1 rad 3, which we're going to multiply by this, which we're going to go ahead and get that. So it turns out that it doesn't matter for a 30, 60, 90. The sine of 30 is always going to be 1/2. The cosine of 30 is always going to be rad 3 over 2. And the tan of 30 is always going to be rad 3 over 3. So let's see what happens with 60. But you know what? Let's skip the what if. Go with whatever you want. I'm going to use 1 rad 3 and 2. 60 degrees. We're over in this corner. Opposite over hypotenuse. Rad 3 over 2. Cosine, adjacent over hypotenuse, 1 over 2. Tangent, opposite over adjacent, rad 3 over 1 is just rad 3. And can you trust me that no matter what, the sine of 60 is always going to simplify to rad 3 over 2. The cosine of 60 is always going to simplify to 1/2. And the tan of 60 is always going to be rad 3. Cool? Special right triangles.